Hello friends, now that we have designed our building, we'll see how you can detail the various structural members. Okay, so in this video we'll see how you can detail the longitudinal reinforcement of the columns. Okay, so the numbers here represent the sectional area of the required reinforcement values. For example, in this column the area of 1494 mm square is required. Same is for these two values as well. Okay, so you can see that the higher value is at the upper floors than the lower floor, right? So while detailing, you have to make sure that while going from down to the top, the reinforcement area value must decrease and it must not increase. Okay, so how you can tackle this problem, we'll see later in this video. For now, we'll just detail this column as an example, and we'll also detail these other columns also. Okay, so for this purpose, we'll be using the Excel for our easiness. Okay, so let's open the Excel. Okay, so let's make a rough sheet. So we'll do bar, so we'll do number of bars, that the area, total area. So this is just a rough thing. Okay, so you can design your Excel sheet as per your requirement, and let's do is that the final area. Okay, so the bar means the bar. So suppose we are using 16 mm bar, so it's the bar numbers. Suppose if we are using 4 numbers of bar, so area means the area of 1 bar. So area of 1 bar is equal to pi by 4 into the bar size square, right? So 3.1416 divided by 4 into this again into this value, right? And hit enter. Total area means the total area of the provided reinforcement, so that is number of bars into the area of 1 bar, right? So we do it as is equal to this into this, right? So the final area is the area that we obtain after adding all the bars. Okay, so after that we just copy this row, just copy it and we just paste it. Okay, so now that we have got the required area as 1494 mm square, so what you have to do, you have to attain that value. Okay, so let's add these two values, so this plus this, so these two make 1608, which is higher than that is required. So let's do with 12 mm bars if it works. The 12 mm bar, if you provide 4 in numbers, the area give us as 1256, but the required area here is 1494, right? So what we do, we again convert it into 16. So 16 number of bars, 18 numbers, right? So it's 1608, which is higher than this value, so we are okay with it. Okay, now suppose that this is your column, right? So this is your column, and we have to provide 8 number of 16 mm bars. So what we do, we provide 1, 2, 3, 4 at the corners, and 1, 2, 3, 4 at the mid portion, right? So this is how you detail this column. Okay, and after that we got 1302 at the mid floor and 1328 at the upper floor. Okay, so earlier I told you that we go from higher to lower values. So what we do, we take 1328 for this floor as well. Okay, so for gaining 1328, what we do, we convert less to 12. It gives us 1256, and if we do like 6 number of bars, if it helps. Okay, so by doing this we got the higher reinforcement area than that is required, but there is problem in the detailing. Okay, so we got 1, 2, 3, 4 bars that will continue from the lower floor to the mid floor, right? But how we will lap these bars? Okay, so we got 1, 2, 3, 4 number of bars of 16 mm at the ground floor, and when we go up, we got 6 bars of 12 mm at the mid. So we got 1, 2, 3, 4, we can lap with the 16 mm bars, right? So but 2 extra bars, we don't have anything, right? So we don't do this kind of detailing. Okay, so we must have a bar at the bottom floor to lap at the upper floor. Okay, so what we'll do, and let's provide a 16 mm bar in 16 numbers and 12 mm bars 2 in numbers. If it helps, yeah, it does. So 1432, which is higher than that is required. Okay, how do we detail this mid floor? Right, so we got 8 number of bars 16 mm coming from the lower floor, right? 1, 2, 3, 4, 5, 6, 7, 8. So what we do, we lap 6 bars in the mid floor. 1, 2, 3, 4, 5, 6 bars. We continue to the mid floor from the ground floor, and remaining 1, 2 bars we lap with the 16 mm bar that is in the lower floor, right? So this is how you detail the mid floor. Okay, let's go to the top floor. And you can see that at the top floor the same reinforcement value is provided, that is 1328. So what we do, we continue these bars up to the upper floor as well. Okay, so at the lower floor what we have got, 16 mm diameter bars 18 numbers. At the mid and upper floor we got 16 mm bars in 16 numbers and 12 mm bars 2 in numbers. Okay, so this is how we detail our columns. Okay, so same thing you can do for these columns as well, and for the rest of the columns you can also do same thing. Okay, what you have to keep in mind is that you have to make combinations of these bars so that you get the reinforcement value that is equal to or greater than the required value. Okay, so this is how you detail your column, and while detailing you have to make sure that while lapping the bars from lower floor to the upper floor, the lower floor bar is of higher size than that of the upper floor. Okay, after detailing you have to draw these detailing diagrams. Okay, if you want to know how to read these detailing drawings, you can find my other course. Okay, so once you go through that course you will learn how to detail all these structural members. Okay, so here it is written column C1, C2, C3. So it means that, so here over here you can see that these two columns have got similar reinforcement values, not exact but similar, right? Whatever reinforcement values you have provided here you can also provide in this column as well. So the columns that have got similar reinforcement values, you can mark them as column type 1, right? So here this column has got a different reinforcement requirement, so this is a different category of the column. Okay, so this is the meaning of C1, C2. Columns that have got similar reinforcement requirement are grouped together, right? And you can represent these things in the plan, right? Okay, so suppose that this column and this column on this grid has got similar reinforcement detailings. So in this situation what you can do, you can categorize these two columns as C1, right? And you can categorize this column as column C2 because this has got the different reinforcement details, right? So okay, so after that, if you see this drawing over here, you can see that, okay, so let's do from the ground floor to first floor. You can see that at the ground floor you got 32 mm bars, 16 in numbers, and at the first floor you got 32 mm bars, 12 in numbers, and 25 mm diameter bars are 2 plus 2, 4 in numbers, right? So what you do, at the ground floor you provide these bars, and the first floor you continue all the bars, that is 12 bars, you continue to the first floor, and rest of the 4 bars, that is or 25 mm bars, you lap with the 32 mm bars, right? So for example I'll show you. So this is your ground floor, let's assume that. Okay, so let's do the ortho mode, and so this is your ground floor slab and this is your first floor slab. Okay, so after that what you do, you provide 32 mm diameter bars, 12 in numbers, in the ground floor, right? So let's turn on the ortho mode, the ground floor, and after that you continue those 12 mm diameter bars in the first floor as well, like this. Okay, so after that what you do, you provide 4 32 mm diameter bars in the ground floor, and after that you have to lap the 25 mm diameter bars in the first floor, right? So for that you take 32 mm diameter bars up to the lap zone, that is the lower L by 3, or you can take up to the upper L by 3, not in the mid L by 3. Okay, so where L is the height of this floor. Okay, so up to the lower L by 3 you take the bar and you terminate it over here. After that you take your 25 mm diameter bar and you can lap like this and continue to the upper floors. Okay, so this is how you lap your bars. Alright, so this much for this video. In the next video we'll see how to detail the stirrups.